We're going to look at complex numbers today and simplifying roots where we may have a complex answer. A complex number is really just a number that has I in it, where I is defined to be the square root of -1. Now, these numbers do have applications, especially when you get into electrical engineering. So just because it says imaginary doesn't mean they do not exist and don't have application. Now, when you take a real number and you take a complex number, so real numbers don't have eyes, imaginary numbers have eyes. If you put real and imaginary together, you get what's referred to as complex numbers. So here we have an example of 5 plus 2i. 5 is the real part, the part that doesn't have eyes. 2i is the imaginary part, the part that does have eyes. Now, if we have this complex number, we'll have its conjugate. A conjugate would be the same as this, but you just switch the sign in between. Remember our differences of squares and how that factors? It factors into the two parentheses, which are conjugates of each other, and that's exactly what it is we're looking at here. So if we're looking at this one here, if we're looking at its conjugate, you're going to just switch the sign in between, remembering how differences of squares factors. Similarly with this, we only switch with the sign in between for its conjugate. Now, keep in mind that when we're dealing with the square root of -1, that's I. So i's will only show up if you're dealing with square roots and a negative inside of your square root. I's will not show up if you're dealing with an odd root or something along that lines. So we're going to go ahead and take a look at these two problems. Now we know -32 is really a -1 times 32 and then your y cubed. So at this point, we're for the most part going to just go ahead and solve this like we did earlier in the chapter, once we go ahead and write it as a -1 times everything else. So we have our 2 to the 5th, which is a 2 squared, a 2 squared, and a 2. We have our y cubed, which is a y squared and a y. Remember, if we have a square root, that's going to cancel out all of these squareds. So the square root of that 2 squared is a 2. Square root of the next 2 squared is 2. Square root of that y squared is 2. This 2 and this y are left inside of our root. And remember, when we did the square root of this -1, by definition at the top of the page here, that is your I. Well, all we have to do is just simplify what's in front a little bit. We have a 2 times 2, which is a 4. We have a y, and we have an I. And then followed by our root. Now, could you put the I anywhere in front? Yes, but it's going to be common practice to be able to put the I after your number and after your variable. So try this problem on your own and then watch the video. First of all, write it as -1 times something. Simplify the root like normal. Then you apply your root to each part. The square root of that -1 is I. Square root of 25 is 5. Square root of x squared. And then the 2 and the x are left on the inside. A little bit of simplifying, and we get 5x squared I with the square root of 2x. Now, if you're dealing with multiplying roots together, or even dividing roots that have negatives in them, you first of all must simplify the roots first. So we're going to simplify these two roots just like we did on the previous page. And so we're going to get a 2i root 3 and an I root 2. So now, just like we've done in previous sections, we multiply what's in front of your roots together, and then multiply what's inside of your roots together. So we get a 2i squared and a square root of 6. Now, think of this. We know that I squared, or the square root of I, if I can talk here, sorry about that, the square root of -1 is I. If I square both sides, my squaring would cancel out the square root on the left side, leaving me with -1. The right side would be I squared. So I squared is -1. So this I squared I have in front is really a -1, And negative 1 times 2 is a negative 2, so we get negative 2 root 6. So along that lines, if we have I, we just said I squared was negative 1. Well, what would I cubed be? Well, I cubed would be an I squared times an I. Well, that would just be an I times a negative 1, which would be just negative I. So what about an I to the fourth? Well, wouldn't an I to the fourth be an I squared times an I squared, or a negative 1 times a negative 1? Well, negative 1 times negative 1 is just 1. If we look at I to the fifth, that would be an I to the fourth times an I, which would be an I times a 1. Well, 1 times I is I to the sixth, which would be an I squared times an I to the fourth, which would be a negative 1 times a 1, which is negative 1. I to the seventh would be an I cubed times an I to the fourth, or a negative I times a 1, which is negative I to the eighth would be an I to the fourth times an I to the fourth, or 1 times 1, so we get 1. And then this pattern continues because I to the ninth would be an I to the eighth, which we know is 1, times another I, so we get I. I to the 10th would be an I to the eighth times an I squared, which would be a 1 times a negative 1, which is negative 1, and so on. So if our exponent's a multiple of 4, it's going to be 1. If our exponent is 1 more than a multiple of 4, we get I. If our exponent is 2 more than a multiple of 4, we get negative 1. If it's 3 more than a multiple of 4, we get negative I. So looking at I to the 37th, you got to ask yourself, is 37 a multiple of 4? No. Is it 1 more, 2 more, or 3 more than a multiple of 4? Well, 36 is the closest multiple of 4, so 37 is 1 more, so it's got to be the purple stuff up here. So we end up getting I. I to the 16th. Is 16 a multiple of 4? Yeah, it's 4 times 4. So if it's a multiple of 4, it's the green over here, which is 1. 43. Let's see, the closest multiple of 4 less than that is 40, so 43 would be 3 more, so it's got to be the red up here of negative I. 33, I to the 33rd, that's not a multiple of 4, but 32 is. 33 is 1 more than 32, so it's 1 more than a multiple of 4, so it's the purple. So we're going to look at simplifying these. So here we're just multiplying together. There's multiplication between the negative 3 and the I, between the 2 and the I, and you can multiply in any order you want. So put the numbers together and put the i's afterwards. So you get negative 6 and an I squared. Remember, I squared is a negative 1, and so we just get 6. Similarly with this one, multiply in any order you want. We get 15I squared, and we get negative 15. This one we just did on the previous page. So here, we're going to just go ahead and work this out just like we've done before with variables. So we'll have to go ahead and distribute our negative sign and then collect our like terms. Here we're dealing with addition in between our parentheses, so you don't need any parentheses, so you just collect your like terms, 3 and negative 2. Your 2 of the i's and your 5 of the i's gives you 7 of the i's. Down below, we need to go ahead and solve this for m and n. But make note, if I said 3 plus 4i is equal to something we don't know plus 4i, well, if they both have 4 i's, the a and the 3 would have to be the same. Down below here, if I said 3 plus 4i equals 3 plus something I, well, the 3's are the same, so what's in front of the i's would have to be the same. Down below here, if I said 5 plus 6i is equal to a plus ci, well, the two parts that don't have i's have to be the same, and the two parts that in front of the i's would have to be the same. Similarly over here, we're going to go ahead and take a look at this, and we're going to have to say, well, the parts that don't have i's have to be the same, and the parts that are in front of the i's has to be the same. Now, if we take the purple stuff underlined in purple, we get this, which we could easily solve. Take what's underlined in green. Notice I'm only looking at what's in front of the eyes. If I did include the eyes, I could have just divided then this. I would have had an eye here and an eye here, divided both sides by eye, and I would have got to this step. Now we just solve it like normal, and we get what n is. Now here we just have two terms times two terms, so we have to FOIL our first terms, our outer terms, our inner terms, and our last terms. Remember, I times I is I squared. Now remember, I squared would simplify down to a -1. Combine our normal i's together in the middle, it gives us positive 1i. So then we get 2 plus I plus a 10, so that we get 12 plus I. One last problem over here. Remember, if we ended up having an I in the bottom, remember I is a square root, and remember we don't like to have square roots in the bottom. So we're going to solve this just like we would if we had a root on one of the terms in the bottom, but not the other term. What we did earlier in the chapter is where we did multiplying by the conjugate. So we're going to do the same thing here, multiply top and bottom by the conjugate. So on top, you can take your 5i, distribute it through to the brownish maroon. On the bottom, you have two terms times two terms, so you have to FOIL. First terms, outer terms, inner terms, last terms. Remember, an I times an I is an I squared. Well, I squared once again ends up being a -1. So on top we have 15 minus 10 times -1. By the way, the 6i and the -6i, they cancel, so we're left with a 9 minus 4, and that I squared is -1. So it simplifies just a little bit on top to a positive 10. On the bottom, we get 9 plus 4. Now, on top, these are not like terms. We can't combine them together, but it's common practice to put the real number before the part that has the imaginary part. Now, is this correct? Yes, but typically complex numbers are written as a real part plus an imaginary part, so you should technically write it as two separate fractions.